Okay, so for the last problem, the summation fx value is 599 and summation fy value is minus 698. Okay, so from this you can find out the resultant value. So the resultant value, this is equal to it is 848.8 Newton. Okay. Now by observing summation fx and summation fy, we can say that the resultant, it is in the fourth quadrant. So here 599 is positive, that means summation fx is towards positive x direction, and this is minus 600. So this is 600.98 Newton, and it is towards negative y direction. Okay. So from these two values, so this is the summation fx and this is summation fy. Okay. So this is equal to 600.98 and this is 599.41. So this is the resultant and this is angle theta of the result. So theta you can find out by using this formula, tan inverse summation fy upon summation fx. So this is equal to tan inverse 600.98 upon 599.41. Okay. So resultant is 45.075 degree. So you can write R is equal to, so resultant magnitude, this is 848.8 Newton and this is the direction. Okay. So this arrow, it represents the x-axis and this is the direction of the result. Okay. And this angle is theta, which is equal to 45.07. Okay. Now the next question is, we have to shift this resultant. So replace the force system by a single force and couple system at point B. Okay. So for that we have to find out the moment at the point B. So actually, so this is the object, that is a given object. So I think this is A, B, C and D. Okay. So resultant is like this. This dotted line, it represents the positive x-axis. And this angle, this is theta, which is equal to 45.07. Okay, so resultant, it may be acting at a perpendicular distance d with respect to point B. Okay. So we have to shift this resultant at point B and we have to show a single force and couple system at point B. Okay. So for that, to shift the resultant R at B, just take the moment about B by all the forces. Okay, so we will find out the summation of moment by all the forces about the point B of the system. Okay, so it is similar to the Varignan's theorem. So this side is actually the left hand side in the Varignan's theorem. So in the Varignan's theorem, we have the equation summation of moment by all the forces about the point B is equal to moment by resultant about the same point B. Okay. So just refer the original diagram. Okay, so here we have already resolved the forces. So I will show the component. Okay, so this angle, this is alpha. Then this angle, this is a gamma. And this is beta. Okay. So alpha, this is equal to, so alpha is 56.3. Then beta is 36.86 and 71.56. So this is 56.3. Beta is 36.86 and gamma is 71.56. Okay. So when we resolve 722, you will have the component as this is 722 cos alpha, that means cos 56.3. Okay. And its y component will be 722 sine 56.3. When you resolve 1000, angle is beta. Okay. So its x component will be 1000 cos 36.86. And its y component, so this is 1000 sine 36.86. When you resolve 632, okay, angle is gamma, so its x component will be 632 cos 71.5 or 56, and y component will be 632 sine 71.56. Now for the moment, we should consider each and every component. Okay, so we will start from 722. Consider its x component. Okay, so its x component, so this component, so this is the direction of the component. Okay, find out its perpendicular distance with respect to point B. Okay, because we need the moment with respect to point B. So from the point B, this line is exactly perpendicular to this line. Okay, so this will be the perpendicular distance. So suppose this point is M. So B to M is the perpendicular distance and it is given as a 3 meter. So first moment, it will be 722 cos angle is 56.3 into distance is BM and it is equal to 3 meter. Okay. Now this moment, if you observe the sense of rotation about the point B, so this is the moment point, then moment will be anti-clockwise. So this is the anti-clockwise moment. Okay. And therefore it is positive. Consider second component, which is 722 sine 56.3. So this component is exactly passing through the point B. Okay. So this is the point B. And this is the y component, which is equal to 722 point sine 56. So this component, its line of action will pass through the point B. Okay. So moment by this force, it will be 0. Because the force is exactly passing through the point B, there is no perpendicular distance. So moment by this component, it is 0. Okay, so consider next force, which is a 1000 cos 36.8. So 1000 cos 36.8. So this is the force value into its perpendicular distance. So what is the perpendicular distance for this component? So just extend the line of action, and from point B, draw the perpendicular. So this is the perpendicular distance. So distance BM, or distance, suppose this point is N, Cn, it is the perpendicular distance. Okay. So for 1000 cos 36.8, distance is again 3 meter. Okay. And this moment, so if you observe the rotation, so force is acting in this direction. Okay. That is this force. So this moment, it is clockwise about the point B. So this is negative. The next is 1000 sine 36.8. So 1000 sine 36.8. So this is the force. Now for this component, its perpendicular distance will be, just extend this line, and from point B, draw the perpendicular. Okay. So this is the BC distance. So I will draw here. This is your point B. Okay. This is the point N. At the point N, this is the vertical component, and this is the horizontal component, or X component. Okay. This vertical component is nothing but 1000 sine 36. So for this component, we want perpendicular distance. So just extend the line of action. From point B, draw the perpendicular. So this point is given as a point C. So BC will directly the perpendicular distance from point B for the component 1000 sine 36.8. Okay. So 1000 sine 36.8, this is the force, into distance. This is 2 plus 2. So this is 4 meter. Now what is the direction of moment by this component about the point B? So this moment will be clockwise. Okay. So this component, it will try to rotate the complete system in the clockwise direction about the point B. Okay. So next is (632) cos 71.56. So this is the force value into what is the perpendicular distance. So for this component, its perpendicular distance we can find out. Just extend the line. From point B, draw the perpendicular. So AB is the perpendicular. Okay. So distance AB is the perpendicular distance for this component. Okay. So AB is 3 plus 3. So this is 6 meter. And this moment, it is again a clockwise moment. So it will rotate the system in this direction about the point B. So it is negative. And last is a 632 sine 71 into its perpendicular distance. So this is the component. Okay. So perpendicular distance will be, just extend this component. So this is the line of action complete. Okay. And from the point B, draw the perpendicular. So BC is the perpendicular distance. So that is equal to 4 meter. And this moment, it is anti-clockwise. So this is positive. Okay. So this is your complete summation of moment about the point B. So I will show for the point D separately so that you can understand. So this is the point B. This is your point D. And at the point D, we have two components. This is X component and this is the Y component. Okay. So X component, this is 632 cos 71.56. Y component is 632 sin 71.56. Okay. So when you take the moment by its X component, so we need perpendicular distance. So just extend the line of action. Okay. And from the point B, draw the perpendicular. So this is the perpendicular distance for this component. So you will write 632 cos 71.56. This is the force into perpendicular distance will be distance B to this point. Okay. So in the diagram, it is A point. So A to B distance is nothing but 6 meters. Okay. Now what is the direction for this rotation? So this rotation will be clockwise. Okay. That means actually force is acting at point D, but we can consider same component at the point A because force is a transmissible vector. Okay. So just imagine if we apply the force at point A, complete system will rotate in the clockwise direction about the point B, and therefore it is negative moment. Okay. Now second moment because of Y component, this is equal to 632 sine 71.56 into. Okay. Now for the Y component, we need perpendicular distance. So extend this Y component like this. Okay. And from the point B, draw the perpendicular line on that component. So this is the perpendicular distance for this component, 632 sine 71.56. Okay. That is a Y component. So this perpendicular distance is nothing but distance BC, and this is 2 plus 2. So this is 4 meters. Okay. Now this moment will be, just consider this component. Okay. Actually it is acting at point D, but we can consider that component at point C. Okay. It is the same force. So if you apply the force at point C, your system will rotate in this direction. Okay. And it is anti-clockwise. So it is positive. Okay. So these are the two moments because of 632. Okay. So now refer the complete equation for the moment. So calculate this value. So this is equal to, just you can give the answer in the chat box. Okay, so from the summation of moment, you will get the answer as minus 2397.74 Newton meter. Okay. So initially you will draw the system like this. This is called as a resultant system. At resultant will be at distance D with respect to point B. Okay. And after that, when we shift the resultant at point B, we have to show one additional couple in the system. So this couple is nothing but summation of moment, which is 2397 or 2.397 kilonewton meter. Okay. And if the question is find out the perpendicular distance of the resultant, then you can equate this answer 2397 equal to resultant moment. Okay. That is a R into D. And then you will get the distance D, which is equal to 2.82 meter. Okay. So actually this is a Varignan's theorem. Summation of moment by all the forces about the point B is equal to moment by resultant about the same point. Okay. So by using this Varignan's theorem, you can find out the perpendicular distance. Okay. So this is the final answer, which is a force couple system at point B. Okay. So I hope you understood this problem. Okay. So note down the next problem on the general force system. So here one object is given, which is a A, B, C, D, E. Now on this object, there are 4 forces, 200 Newton, which is acting at point A at this angle. Okay. Next is 40 Newton. Then next 100 Newton. And last is 80 Newton. Okay. There is one additional couple present in the system, which is a 40 Newton meter. And question is, determine the resultant and locate it with respect to point A. That means we have to find out the distance of resultant with respect to point A. So your first step will be, we have to resolve the forces which are inclined. Okay. So there is only one force which is an incline, and it is nothing but 200 Newton. Okay. So you can redraw this diagram. Okay, so at this point we have the force which is 200. Newton. Its angle is not given, but it is given as 3, 4. So suppose this angle is alpha. So this is equal to tan inverse 3 upon 4. Okay. So tan inverse 3 by 4. So it is 36.86. So the angle with respect to this x-axis, this is 36.86. Okay, now resolve the forces. So you can draw the x component like this, and this is the y component. Okay, so this x component, it is adjacent to the angle 36. So its value will be 200 cos 36.86. And y component is opposite. So this is 200 sine 36.86. Okay, so remaining forces, they are exactly vertical and horizontal. So this is 40. This is 100. And this is 80. Okay. And at this point, there is one couple present in the system, which is 40 Newton meter. Okay. And with respect to point A, we have to find out the location of the result. Okay. So after resolution, you can write summation fx. So for summation fx, this is the first component. It is towards positive x direction. So it is 200 cos 36.86. The next is 100. Okay, only 2 forces. So find out this value. So it is 260. .02 Newton. Then summation Fy, this is equal to. So this is the y component for 200, and it is negative direction. So it is minus 200 sine 36.86. Next is plus 40. And this is minus 80. Okay, so get this answer. So this is 159. This is negative 0.97 Newton. Okay. So as summation fx is positive, its direction is towards positive x direction. Summation fy is negative. So actually this is 159.97 and towards negative y direction. Okay. So from this we can locate the quadrant of the resultant. So resultant, it is in the fourth quadrant, like this. So this is the resultant and this is angle theta. Okay. So calculate the resultant magnitude. So R is equal to, in the square root, summation fx square plus summation fy square. Okay. So calculate this value. So resultant is 305, 305.29